Hey everybody, and welcome back to Cognitive Psychology. What I want to do in this video is very quickly walk over the last week's material and then jump into this week's material and take a quick look at the upcoming exam, which is going to be at the end of this week. So last week we looked at visual perception, no pun intended, but basically this chapter is all about visual integration and how we were able to process things visually in the environment, particularly looking at top-down versus bottom-up processing, but also looking at the different ways that information flows throughout the brain. So this particular chapter can be kind of nitty-gritty, and from here on, we're kind of getting bigger and broader and more abstract as we move on. So this week's discussion was looking at the go, no-go task. And so the go, no-go task is a very basic cognitive experiment that is used in all kinds of facets of cognitive and just psychological research. But here you may remember basically you have to press a space bar whenever you see an orange square. And based on your discussions, a couple of things became clear. Number one, for some of us, the data didn't download. It wouldn't download on your computer. And it seems like maybe the other half of us, when it did download, it was just kind of a frustrating mess of a spreadsheet. So you don't have to worry too much about the accuracy of your times here. I've already graded a lot of these discussions, and so I'm not penalizing you because of these kind of computer errors or whatever. But I think a lot of you kind of got the idea, which is, how quickly you move through this. And what your average speed might be like. And so really I'm more interested in these second and third questions. So does this only measure visual perception, and does this tell us anything about the real world? So a lot of it, I was so happy to see, like, basically most of the people in the class got really insightful with questions 2 and 3. So in 2 and 3, here, is it only visual perception? No, not really. As some of you observed, it does require attention. It does require memory, so you have to remember what the rules are, what the instructions are while you do this. It measures maybe response time, motor control, response inhibition. There's lots of different behaviors that this kind of taps into, and that's kind of important because if we are trying to make any kind of conclusion about what we are measuring, we have to make sure to account for all these other things too. And so just something to think about as we move forward, looking at these basic cognitive psychological tests about what's actually being measured, and maybe more importantly, what else is also being measured as we are collecting this data. So the third part here, what does this task tell us about real-world behavior? There's lots of different kinds of responses here. Some people said that they didn't see it at all kind of related to the real world. Some people said that they felt like, you can imagine it while you're driving with, red lights and green lights and things like that. And that's good too. But for those of us that mentioned that they didn't see a real world kind of analog here, I think that the important thing to consider, at least, is that a lot of the things that we're going to be talking about in cognitive psychology are very basic. They're very basic psychological phenomenon, and it can be hard to see how this is relevant outside of the laboratory setting. And that's because we're trying to study the most fundamental parts of that behavior so that we can understand how these other bigger, broader behaviors work. And so, as an example, any kind of task that you would do over a set period of time, let's say taking notes, for example, could be relevant for this particular task, because this task is basically, studying how do we engage with behaviors and disengage from those same behaviors, which is what note-taking is. It's what driving it is. It is what being in a conversation is all about. So a lot of these things aren't clearly like, it can be hard to see the connection, and that's because they get so contrived, I guess you could say, in their laboratory settings. Okay, that's too much time on chapter 3. Let's look at chapter 4. So chapter 4 is all about object recognition. It's going to be very closely tied in with chapter 3, where here we're mostly going to be looking at how we are able to recognize objects and how we're able to recognize faces. Those of you that have taken sensation perception are going to recognize a lot of this information, and that's great. Format is very similar, where we have the quiz and we have the discussion. The discussion is going to be kind of similar to the last one. In Chapter 3, it's going to go by much faster, and the data are a little bit easier to access. But here, I'm going to be testing whether or not you are a quote-unquote super recognizer of faces. So I want you to take that test and then reflect a little bit about what your performance was like and perhaps how it might be better there. And that's pretty much it for Chapter 4. The two big things to consider, though, is that all this is due Friday, but so is your research paper. So your research paper here, which is the Chen 2018 article, this particular paper is about expertise and recognition. And so it's going to be very relevant to a lot of the things that we're going to be talking about in Chapter 4. And so to give you a very quick run through of what to look for, this is basically they're going to take two different kinds of groups. They're going to take people who are experts in reading x-rays, and they're going to take people who are pretty good, maybe not experts, but they're residents in training, so they have some background in reading these things, but they're not novices. They're much better than you and I would be, but they're not, experts in this particular thing yet. And so what they basically do is they're going to have people do a very quick task. And in this task, you can kind of see it right here when you open up the manuscript. So for panel A, basically what you're going to do is you're going to see this fixation cue. So your eyes are sitting right here. You're going to see this x-ray for 1 whole second, and then you're going to have this visual mask where it scrambles basically everything, so that way, long story short, you don't have any kind of trace memory of what you just saw. And then you have to make a decision. Was that particular x-ray, was it normal or was it abnormal? And so that's pretty simple, right? The second part of it is going to be the exact same thing with faces, where you're going to be looking at the face and then you're going to ask whether or not it's a neutral face or a happy face. So in both cases, you're making some kind of visual perception distinction or response behavior towards these things. Then they're going to flip these things upside down and do the same thing. And what they find is essentially that for people that are faces, it doesn't really matter if you are a expert or if you are a resident. Basically, performance is the same for faces. So if you're an expert radiologist or somebody who's just a radiologist in training, for faces, it doesn't matter what the orientation is. You do equally well regardless of your background. But for the mammograms, for those x-rays, we see there are differences. That the experts are in some cases better, in some cases worse at their ability to perceive differences or abnormalities in these x-rays. And so you're going to see a lot of this dependent variable, they call it D prime. D prime is just a sensitivity measure. Don't worry too much about the math that underlines that. Just think about it simply in terms of that the higher that value is, the more sensitive you are to making perceptual judgments about that particular image. So the higher, the better. The lower, the worse. As this gets closer to 0, performance becomes closer to chance, basically. And then later on they kind of parse out this data and look at it in terms of how training and how years of experience affects performance on these things. So I think it's pretty straightforward, but it can be very easy to get bogged down in the minutia, in the jargon. So if you have any questions, please let me know. I know there's already been 1 or 2 people who have already submitted this, but that's okay. If you have any questions or want some feedback, just let me know. The other part is going to be the exams. Now, if you click on the exam, you see that there's nothing here yet. I have it made, but I'm still tinkering with it a little bit, so you can expect it to go live within 24 hours. Once it's live, you can take it whenever you want. It's just going to close Sunday before midnight. So if you want to, you can knock out all of the assignments by Friday and then have just the weekend dedicated to the exam. The exam is going to be over all the information we've covered so far this semester, so chapters 1 through 4 and the research paper. And you will have 90 minutes to complete it. It's going to be roughly 10 short answer and 10 multiple choice. 10 fill in the blank and 8 short answer, or somewhere thereabouts. So it's only 18 questions, which sounds like you have a lot of time, but I'm warning you that if you go into it thinking that way, where you're prepared to, you have your book next to you and your notes, and you think you're going to look these things up as you take the exam, time is going to run out for you. And so I don't want that to happen. I want you to study as much as you can beforehand, so that way you don't feel too pressured with time constraints whenever you take that exam. But I think that's pretty much it. So you can expect that to show up here. And let me know if you have any questions whatsoever. I look forward to talking with you throughout the week, and dropping in on the discussions to see how well you remember faces. All right, I'll talk to you later. Bye.